All right, so again, property sheets. We had a lot of properties, the properties of, equality versus the field properties. The properties of equality, you really kind of tend to only use one unless your problem requires like the 8 steps that we talked about yesterday. So like for instance, if you had a problem that looked like this, let's say the problem was x divided by 3 is equal to 10. I think we did an example like that yesterday. This problem only requires 4 steps. The reason why, you only have one number to get rid of on the side with the x. So it takes 4 steps. Your 4 lines of work, number 1 will be a property of equality. That's what we talked about yesterday. You only tend to use one of them, and you only use a property of equality when it contains an equal sign. So like when I look at that problem, it does have an equal sign, so I know my first step has to be a property of equality. It's basically, what are you doing to both sides? The second step that you do is you'll always do an inverse. So there's 2 types of inverse. There's the one where you do property of opposites, where you add numbers together to make 0, or in this case, you'd have to be doing reciprocals, because you're gonna have to multiply or divide numbers to make 1. Because I will have to make 1 on this side to cancel out the 3. So that would be the type of inverse. So there's only 2. It's either you add to make 0, or you multiply to make 1. So by just looking at the problem, I already know that I have to do a reciprocal, just because I know I have to multiply. The third step is you have to do some type of identity. Now that requires, the identity relies on what inverse you did. Since I'm multiplying here, I'm going to multiply or divide to get that 1 for reciprocal. I know the identity I'm using is multiplicative, because I'm multiplying on this type of problem. I'm not going to be adding or subtracting. So that's the identity, so I have to do the multiplicative identity. And then the last step is you always do substitution. So before I even start, I already know my path. It's like, you only have one path when it's a multiplying problem. You only have one path if it's adding or subtracting. And so you just have to remember your 4 steps. That's why I tried to go through 2 examples yesterday, kind of like one of each type, so you could see kind of what property you automatically have to do when you look at your problem. There's only like one lane you have. So it's not like I'm making up stuff, it's just the same properties. So if you get it memorized, that's it. It's the same properties over and over and over, and you just rinse and repeat when you go to the next problem. So in this one, I have to multiply by 3. Right? So I'm going to multiply by 3 to both sides. That way these 3's cancel. That's the opposite of dividing. So it's the multiplicative property of equality, right? Multiplication property, or product property of equality, right? Then the next step is all these 3's would cancel each other out to make 1. And notice on the right side, I'm not doing anything with that 10 and 3. Now the inverse I just did, that was your reciprocal. Reciprocal is when you multiply or divide numbers and they make 1. Because they cancel each other out. 3 divided by 3, that's how it works. And then when I multiply by 1, that's the multiplicative identity, multi-identity. And again, you're going to have to do the multi-identity if you know you're multiplying or dividing right away. So it's like it's automatically set what properties you're doing. Then the last step is substitute. Okay, the third. Substitute. Okay, does it make sense like the properties that you're doing? Like it's an automatic. It's so weird that, people that really struggle with this, it really just comes down to kind of memory. Can you kind of memorize what you need to do? Do you have examples in your notes that look like it? Because it doesn't matter the numbers I pick, or if this is a multiplication versus a division problem. These are going to be your property names. The steps don't change. So it's always it's odd to me that some people really struggle with that. You just have to know what 4 steps you're taking. You only have 4 options, right? You only have the 4 steps you have to write. Now, the other side of the coin is if I did something like this. X minus 12 is equal to 30. Say that was my problem. Well, that problem requires the same 4 steps, but the things that would change. I'll be adding or subtracting first. So that property of equality changed. And then since I'm adding or subtracting, that changes my inverse and identity. The inverse, I have to use property of opposites, because that's the one where you add or subtract. And then the identity, I'll have to do the additive identity, because I'm adding or subtracting. So that it tells me my plan that I have to do. So I have to add the 12 to both sides. So that's the add property of equality. Right? So then I'll do the property of opposites. This makes 0. And notice on this other side, I don't even touch it. I'm only dealing with one side until it's simplified all the way. So that step where I made the 0, that's your inverse, that's your prop of opposites. That's the inverse. Then the identity that I'm doing is additive. Because you have to add the 0 to something. That's your add identity. Then your last step is to substitute and tell me that this is going to end up being 42. Okay, those are your only two options. No joke. Those are the only two options, whatever problem you have. Now, if you have a problem that has, it's a two-step problem, where you have to like add or subtract first, and then you have to multiply and divide second. I think you had 2 of those in your worksheet, correct? It was like problem number 2 and 4 or something like that. It's the same properties. It's the same ones. All you're doing is you're doing like one of these first, and then you'll do this part second and finish up the problem. Because when you solve equations that have 2 steps, right, no matter what your problem is, let's say it's something like this. Let's say that's your problem. I know I have to add and subtract first. So I'll do these 4 steps right there. Because I have to get rid of the 1. Because the order of operations that you do is called SADMET. It's PEMDAS backwards. Right? You have to add and subtract first. Then you have to multiply and divide second. So I'll have to do all these 4 steps to add to get rid of that 1. Then once the 1's gone and I have, 3x equals 12 eventually, then I'll do these 4 steps to get rid of the 3. So it's just rinse and repeat. Questions with kind of what you're doing on that homework assignment that I sent yesterday?
No.
Okay, it's due when?
Friday.
Tomorrow, Friday. Okay, so keep that in mind. Okay, I'm going to give you some time to work on it today. I really just kind of want to intro the next type of problem. These properties don't go away, so don't feel like I'm getting new properties. I'm not. We're just going to really kind of focus on the new stuff today. So I'm just going to do maybe an example. I want to go about less than 10 minutes here worth of notes, and then give you about 20 minutes to kind of work on that worksheet today, so you get some time. Maybe you're done, I don't know, or maybe you haven't even started. So I do want to give you some time. If you have questions, you can ask. I'm here. I don't want to send you home when you don't know what you're doing. So yeah, so questions currently on what we just did. Hopefully you have notes on that. It's really smart to take notes, especially when I'm telling you that's the order of the properties, they don't change, that's it. Or when you multiply and divide, these are the property names, in order, no joke, they have to go in that order. Okay, all right, let's deal with our new problem today. Does anyone still need that though? I don't want to erase that if somebody needs it.
Can you just leave the order quick?
That one?
Yeah.
Yeah, we'll leave that up on board. Okay, I'll leave that just for right now. All right. Now, let's talk about our new problem. I'm going to do one new problem. Okay. We're going to do expressions now. We've been doing equations. I'm going to draw a line here. We're going to deal with expressions. What's the difference between an expression and an equation?
No equal sign.
No equal sign. It will require a different particular set of skills, right? It requires the steps are a little bit different. You don't follow that order. That order is really good for equations, right? You do a property of equality, you do your inverse identity. But on an expression, different. There's 2 types of expressions that you could have, and I'll kind of explain. I'll give you the 2 examples right now. This is the first type of expression you could have, something like this. Like that, where maybe you just have to combine terms, right? You just move some stuff around. Notice no equal sign. You're just going to combine terms. That's one type of expression. Now, obviously, I could change those to be anything. Different letters, different powers, whatever. That's one type of expression. The other type of expression is something like this. That's the other type of expression. It's when you have to distribute, right? You have to do the distribution step where you have to multiply something into the parentheses because I can't add or subtract these. those are the only two types that we ever deal with. So each one requires 3 steps. 3 steps to solve. That's the weird thing. When you do expressions, they're usually easier. You just have to learn the process for how to do it, how to show your work, how to show the correct steps. Now, I'm not joking. You probably know the answers in the first second I wrote it on the board. You know that that one over here is 8x plus 13. You know this one's going to be 10x minus 50. Like, I know that. That's great. You know the answer. Perfect. You already know what, your third, fourth line is going to be, whatever you're going to write. The problem is there's middle ground that actually explains why does something work. So that's what I want to look at today. I just want to do expressions. I want to intro this for the first time. I do not expect you to be the expert at this when you walk out. I just want you to see it. And then tomorrow, we're going to really kind of hammer this down. I'll give you a bunch of examples, and so you can really see how they always work. Okay? All right, does that make sense what we're doing today? All right, let's start with the first one. These are my only 2. Once I'm done with these notes, you can work on your worksheet. Okay, that's all I want to do, just intro this today. Okay? All right, so first one, let's start with this one on the left. I want to combine like terms. So when you look at that problem, what are the things that I want to add together? 2 and the 11. Okay, and what else is the other thing I want to add?
3x and 5x.
Okay, we all agree. You want to combine what they call quote unquote like terms, right? Before you just add them and you just say 8x and 13, you need to move them so they can physically see each other. Imagine that they can't see each other because the people that are in the way, the 2 and the 5x, like they're people and they're standing in the way of each other and they can't see them. They can't see the outsides. So I'm going to rearrange the problem. I'm literally just going to move things around like this. You're always allowed to do that on a problem. Notice, they're not changing signs. It's not becoming negative or anything like that. Because I don't have an equal sign. I'm not moving across the equal sign. I'm not doing the opposite. I'm just moving them around. It's not changing my numbers. It's not changing the answer to this problem. That simple fact where I move stuff is one of your properties. What property did I say the other day that you have to group and move? It was one of the hints I gave you. To group and move. So I read that. Commutative, yeah, you commute. This is the commutative step. The commutative property is where you group and move. If you commute to work, you group up with your coworkers, you get in one vehicle and you move. You group and move. That's why we use the commutative step. It's for like terms. Most people do this step in their head. They look at a problem and they start picking up the things that they know they need to add. You're commuting in your head, you're just not physically writing down what you're doing. This is the step you have to show me. You have to show me that what you're going to group together. Okay? Does that make sense, the first step? Okay. Now, this is the step that I'm betting on that you've never seen before. Okay, everyone knows, what's 3x plus 5x? 8x. Okay. There's a little bit of work you have to show. Because right now, I know this seems weird, the 3 and 5 cannot see each other. The x's are in the way. So you have to pull the x out of the parenthesis. So it's like distribution. It's called factoring. It's reverse distribution, if you will. You have to pull the x off of them. Both of them have x. Think of x as like a label. Like you have 3 candy bars and 5 candy bars. So I'm going to put the candy bar labels in the back and just add the digits together. Okay? Now, this, I know this seems really weird. This is not associative because I didn't have parentheses to begin with. So I'm not doing associative. This is distribution. It's just doing it backwards. It's the distributive step backwards. Sometimes my geometry kids call it reverse distribution. Its correct term is actually called factoring. I don't know if you've ever done factoring in Algebra 1. I have no idea what you ever did in Algebra 1. I haven't taught algebra for a very, very long time. Well, that's the property you distribute. You pull the x out. And so you're just looking at the numbers so they're side by side. Notice I haven't added yet. I'm just trying to get things in a position where the numbers can see each other. And your last step. What's 3 plus 5? 8. Okay, because now they can see each other, so now you can add them. So that's 8x. because now the numbers can see each other. And what's the 2 plus 11 in the back? 13, because those can now see each other, right? They're side by side. That's substitution. Simple arithmetic, right? You're adding and subtracting random numbers together. It's usually the last step. It's usually the closure step. It's the closing step of your argument. As I told
There's
you,
only 3.
it's only usually 3 steps. Because it's not an equation, so they usually take 3. Question?
That's what I was gonna ask.
Yeah, it's usually a 3-step process when you do it, every single time. And the weird part is when you do the expression like that, it's always the same 3 steps. You'll commute, move things around. Then you'll, usually reverse distribute if you have a bunch of variables so that the numbers can see each other. Then the last step is usually substitution. That's it. You simplified, you're there. The other problem, so if you look at the other expression, it will also take 3 steps. So usually expressions take 3s. So on this last one, this is my last problem of the day. Okay. All right, so on this one, my first step, I need to distribute the 5 because I cannot add the 2x and 10. They're not the same like terms. It's not like I can just substitute and tell me what the answer is. So I need to distribute the 5. When you distribute the 5, you just merely hand it out. This is it. Notice what I did there. I'm handing the 5 to each. Your mailman or mail carrier or mail woman, whoever it is, the carrier that you have, will hand out the mail. They don't do anything with it. They just put it in the mailbox. I'm putting the mail in each neighbor's mailbox. I'm not opening it. I'm not doing anything with it. Just give it to each, distribute it, disseminate it, hand it out. Okay, that's distribution. That's it. That's the simple fact to distribute. So distribution works 2 different ways. You can either hand an item out to things like that, or you can rip the same item off of each like that. This was called reverse distribution. The x is coming to the outside. You're ripping it off of the 3 and off of the 5. So the mailman's walking around to the mailboxes and taking the mail back out again. They delivered it to the wrong house. Make sense? Okay, so that's distribution. Now, there was a property on your property sheet that I said, every time you do distribution, it is 100% guarantee your next step you're going to do when you do normal distribution, this is normal where you hand things out, what does the next property need to be?
Substitution?
Not sub, not sub.
Oh. Associative?
Associative. That should have been a little clue you should have had on your property sheet. I think we wrote that on Tuesday or maybe it was Monday or something like that, where I said, anytime you distribute, it is 100% normal distribution. You will do the associative step next. The reason why, do you agree that this problem has parentheses in it when you distribute it, right? You hand the 5 out. I have to move them because the numbers can't see each other. The 5 and 2 can't see each other, and the 5 and 10 can't because the parenthesis bars are blocking it. They can't see each other. So you have to physically move the bars. So I'm going to move the bar so it's around the 5 and the 2. I'm going to move the bar so it's around the 5 and 10. Like that. Now if you want to get rid of them, fine, but they're still there. They're technically there. They're just around the 5 and 10. Okay, that is associative. Now, what was that property you said earlier?
Substitute.
Substitute. Now the numbers can see each other, so now you can do the work. What's 5 times 2? 10. And 5 times 10? 50. And that's substitute. Done. Again, I don't expect you to be an expert. Today is the intro day, to show you the first problem so you know what we're going into in the next couple days in here. And this is just kind of breaking down what we're going to be doing. Obviously, your homework today is based on all equations, so you have to do the 4-step process. But the next step we're going into is the 3-step process. Okay, questions? Yes.
I'm gonna move, like, this over there.
You're going to want to add both sides. So you additive property first. You're going to have to add both sides. Yeah. Add first. Yeah, you're done. You can put the worksheet there.